cool demo, so I've got to be hands-on, so I was hoping this would work here. Last session they had to hold it, so if it's not loud enough, speak up and I'll hold it for you. So I'm Adam Mollenkops. I'm the real-time GIS capability lead at ESRI, and what I'm responsible for is the big data streaming in and doing analytics on that. What we found is we actually, take that data in, and then we need to store it somewhere, and then it becomes another big data problem where we need to do batch analytics. So what I'm going to share with you today is some of the work we've done at ESRI around this. A real quick slide on ESRI and who we are. We were founded in '69. Our owners and original members were the original folks that founded GIS back in the day. So these are the guys that invented it. They actually still work at ESRI, and we're recognized worldwide as the leader in the geospatial space. We develop all kinds of different GIS software for desktop, mobile, server, as well as deployments throughout many different user organizations around the world. We have 80 distributors. Our headquarters is about an hour and a half east of here, and the rest is out in the Inland Empire. So one other note before I jump into the topic, we are a certified partner of Hortonworks, so if you guys happen to make use of that distribution, you can certainly make use of ESRI on there. We do the same with Cloudera and other folks, we're just not a certified partner with them at this point. So what I'm going to talk to you about is, I'm going to talk a little bit about what ESRI does as far as product, and then I'm going to ignore the products and just talk about the technology, because I think that's what we're here to talk about. You guys don't really want to know about our products, you want to know about what's the technology behind all this stuff. Okay, so to frame the context of what we're going to discuss though, the problem that we solve is being able to ingest data from a wide variety of sources. Those sources can be social media providers like Twitter, Instagram. They could be black boxes in vehicles that are emitting GPS locations. They could be sensor networks on a power line utility network. It could be aircraft or military equipment. It really could be anything that streams data and reports its location. So that's really what we're about, is bringing all that data in and ingesting that data. So what we use to do that is Kafka and Spark streaming. And I'm going to deep dive into each one of these topics and talk about the technologies, share with you some of our benchmarks that we've done from a performance perspective, and also what we've found to be the best practices to use. When we ingest the data, we might want to do some analytics on that data as it's received. So as we receive an event from a vehicle or a social media provider, we might want to run analytics on that. That analytic could be, is this guy going into a dangerous area? Is this guy meeting up with other individuals that I'm interested in? So performing geospatial analytics on the fly as events are happening. We also need to store this data somewhere. So a lot of our users and organizations that make use of our products want to not only consume the stream, but they want to store it long term. So something that's streamed in today might not be interesting today, but we find out tomorrow that something happened yesterday, we need to go back and look at that data. So being able to look at the history of this information is really important, and also look at trends over the reports and all the GPS things that are coming in over time. So that's where the batch analytics comes in. And for storage, we make use of Elasticsearch and the Spark connector for Elasticsearch. We also have a batch analytics capability, which is based on Spark, and then finally there's visualization, which I'm not going to really talk about too much in this session, just very briefly so that we can illustrate the demos. So that's it for the product stuff. Now I'm going to deep dive into the technologies, which I think is what we're all here to talk about. So how do we ingest high velocity data? And more specifically, how do we ingest data that's spatial temporal in nature? What I mean by spatial temporal is it has some aspect of space. So it's either a point that has a longitude, latitude, or it's a weather front that's coming in and we're listening to weather polygons that are moving, that are warning conditions, or it's a line that might be moving. It's a boundary that is in a defense deployment where if something crosses this boundary, I want to know about that. So it has some kind of aspect of space. It might also have some type of aspect of temporal nature to it. So it reports a time whenever the events are happening out in the field. And that time needs to be treated as a first-class citizen. So we need to treat these events in a spatial temporal way. We might also receive events that don't have space changes. It might be a sensor on a network that doesn't move, but its attribution changes all the time. We want to be able to bring that data in and analyze that over time. So for ingestion, the requirements that we had when we were selecting technology for this is we need to be able to sustain thousands of events per second, tens of thousands of events per second on a single node. So we should be able to also set up other nodes that cluster with that that we can scale in a linear fashion. So if I can process 50,000 events on one node, I should be able to add a second node and get near 100,000 events per second. Another big important thing for a lot of our customers is being able to handle graceful nature of bursty data. What I mean by bursty data is there might be vessels that are traveling all around the world, and a provider that provides this vessel feed gives us an update every minute, but it gives us an update for 500,000 vessels all at once. So it's not coming in a nice, even kind of way. It's coming in a big way every minute. And we need to be able to handle that bursty data that's coming in a big way. So those are our requirements for selecting technology to do the ingest. We evaluated a number of things. If you're interested in comparison of things that we looked at, talk to me afterwards. I don't have enough time to get into it in this session. But we looked at RabbitMQ, Flume, ActiveMQ, a number of other things, Kinesis as well. What we found to fit our best need was Apache Kafka. And Apache Kafka, if you're not familiar with it, is basically a high throughput distributed messaging system. And it shifts the paradigm from a message bus to a distributed commit log. So it's much more efficient and it can handle much more throughput than a lot of these other systems that have message queues and write-ahead logs and other types of things with them. So it's very fast. A single node, we'll talk about performance in a minute, can handle hundreds of megabytes per second. And it's also very scalable. If you need to add more throughput, you simply add nodes to your Kafka cluster. It's also durable, so if consumers aren't consuming the events, you can actually persist that and keep that in midterm storage, so that when clients get back online, they can pick up where they left off, so you don't lose messages in that way. And it's also distributed, so it provides fault tolerance, so if you have partitions on some machines, it'll be fault tolerant and move those over to other machines. So the other technology that we use to do the ingest is Spark streaming. So Spark, you'll probably hear this hundreds of times during the day today, but Spark is the new paradigm of doing large-scale data processing. And what was really attractive to us was we needed to solve the real-time problem and the batch problem. And we didn't want to write our analytics twice. We wanted to write them once. So what Spark provides is a unified big data processing engine and an environment for us to write these jobs. We can write those in any language that we prefer, Scala, Java, Python, R. We write our stuff in Scala just because that's the closest to Spark, and we do lots of good things with Scala, and it provides a lot of additional capabilities over the other languages. What's also cool is you can actually combine streaming with batch. So if I'm streaming data in, and I actually want to query to maybe enrich the data that's coming in, I can query that through a batch analytic, and then add enriched information onto that event. So maybe I get a really dumb message from a device that says, I'm device ID this, and here's my position. I probably want to know who the driver is or who the person is. I can look that up, keep that in memory in a cached RDB, and then when events come in, I can enrich that event so downstream things in the analytic workflow can use that. So I can say, if you're a blue force or a red force, I'm going to treat you differently and do different analytics. So to share some of our performance benchmarks, I'll qualify this with the machine, and the size of the machine is up there on the right. It's a standard AMI instance that's on EC2. The messages that we were sending through this were small messages, so it was, here's my GPS report, and here's 10 or 15 attributes, so very small messages. But we were able to sustain about 132,000 events per second long term using Kafka and Spark, and this is just on a single node. So if we add a second node to this, we actually do experience linear growth. So it's actually better than linear growth. And as you add more machines to this, you continue to see the same trend. So we tested up to about 5 nodes, and the rates that we were getting were plenty sufficient for the use cases that we had for our customer base.